Hello, everyone, and welcome to Core Protocol Sync this week. We'll share updates on the DSN and consensus and event execution part from last week and what we are planning to do next. Shamil, do you want to kick us off?
Sure. Last week, I modified our implementation of custom record storage for Kademlia. I prepared ParityDB version of it. It uses basic operations of the database for put, get, or remove Kademlia operations, and it uses B-tree iterator for the record listing. This implementation will allow us to store pieces for farmers locally in the cache. We discussed this topic with Nazar, and I will probably have another iteration with L2 cache and try to implement pool model, but I need to experiment it first. Also, to implement that second iteration, I need a discussion about cache expiration policies for both nodes and farmers. We have nodes producing pieces and farmers storing pieces in their L2 cache structure. And the question is how to limit those caches. In fact, there are two separate questions because policies are different for different peer types. And for nodes, there is an idea to store pieces for some limited time and then remove them. As a precaution, we could also evict pieces from the cache only after receiving and downloading requests. However, Nazar suggested to limit just the size of the cache and replace all these pieces with new entries without additional conditions. There are pros and cons for each solution, and I want to discuss it. Also, for farmers, current idea is just to have cache limited by size only, and new pieces replace old pieces just by Kademlia metric. And I think it's good for now, just worth mentioning that. And since we're going to finally merge the huge PR with new consensus with you, my next task, I'm going to start it, let's say, the very next task, would be integrating DSN with the new consensus. It will be iterative process. I would start with getting pieces from nodes only, and then add L2 cache to that structure, and then to reconstruct pieces from archival storage. So it would be in several PRs. That will be my next task. Thank you.
Actually, on the cache that is in the node, what they meant is to have a limit on size. That's like the default, but also have an expiration time. Let's say like a day or 3 days or something. And we will store pieces regardless of their expiration within that size limit. But if we happen to have more data within the time limit, we will store that as well. So it's like two parameters. So you
Yes,
don't.
and I a little bit cautious about that situation when we will have pieces that were not chosen for some reasons for plotting. And what about them?
Sure.
We need to calculate this probability and pick the time with some math behind that.
Yeah, Jeremiah, we discussed this. I believe there is a different algorithm coming, right?
Yeah.
About how we do reporting.
Yeah, let's discuss that after. But I think we're probably generally on the same page from the comments I saw. Yeah, and just Shamil, with respect to the integration, that's going to be key to try to get things merged in so that we can. I guess that's kind of a theme for everybody right now on the call. From my point of view, is getting to the point where we can test, consensus v2, milestone 1, which Nazar's recently pushed, along with the new DSN, along with the system domain and the new execution layer, trying to get to like a full integration of all that on like a live test network. That's what I see as sort of the next major milestone for the protocol right now.
Yeah, sure. For me, it's the very next task.
Yeah, we actually discussed today how that can be integrated. I was showing some parts that are relevant. Okay, Luchain, what do you have to share?
Actually, like on the co-protocol side, like particularly the perma chain. Anyway, let me share my screen. Okay, so on the perma chain, like the changes like is mostly related to the valid executor, which like particularly about like validate these like new bundle election in the bundle. Like that's a thing I would like to let you know, like that previously we don't particularly check the state roots of the secondary chain block. So here we basically need to check that so that we can like verify these state roots like included in this like proof of election like is like actually correct. I will do it in a follow-up PR. And another like general problem of the question is that Red also mentioned this like in a comment, like he like mentioned that using the domain ID as the associate like type in the like palette config. I am not like entirely sold like that is really necessary because in my opinion it's kind of a low level concept and there's no need to be configurable for the domain ID. So it's probably simpler to just use like a unit type wrapper or just an alias to the primitive like U64 as the domain ID type. So what's your opinion? Is that? I believe the comment was, yeah, this one.
What you said
I don't
makes
know.
sense to me.
Not
Luchain.
entirely sure. Yeah.
I think it's just kind of an opinion matter. In this case, I think it's better to defer to you since this is your responsibility. But we can talk about that more in the integration sync if there's any big concerns. I think it's one of these things where it's kind of like 6 of one, half a dozen of the other. It doesn't really make much of a difference. Like they can both work. And since you're primary on this piece, we should just defer to what your judgment here.
Yeah, if it was substrate, then it would make sense to make it a generic type, but in this case, probably doesn't matter.
Yeah, and I do think it's like much simpler without using the generic type. So actually, no like major comments I would like to talk about. Actually, there are like some important things, like important questions we need to figure out. One of them is like how many executors can we support? Actually, like regarding the storage proof size, like the computation cost to iterate, or the storage cost to iterate the entries in the runtime about the executors entries. Yeah, that's my thoughts. Yeah, so far.
Yeah, my more general concern there was that it appears that we are using or like we are cloning all active executors at a particular point in time and just using all of them instead of selecting a group of them temporarily.
Well, we basically have to make use of almost the entire group of the executors because we don't expect that there's too many inactive executors.
Right, but it doesn't mean that they are all potential candidates, but it doesn't mean that they all should be used. We can elect like a group of them, like in proof of stake system.
Yeah, but that's not the design. It's everybody gets chosen. Everybody's part of the election each time. It's not like a subset election.
Well, then we have these performance concerns because proofs are not actually proofs, just literally clones the whole thing. And when we need to do something about it, we are like reading a lot of keys. And we are cloning a lot of data in the runtime during block initialization.
Actually, it's not clone the whole thing. I mean, it's only the public key and the stake weight. Right.
But still, if like it's just thousands of executors, it will not be.
Yeah, we are
relative.
targeting 100K. Yeah.
Yeah, I think at this stage, these are valid. I mean, your concerns here are valid, Nazar. But at this stage, we should be more concerned with getting a working test out rather than having something which is like perfectly scalable. So I would rather just accrue a little bit of tech debt here and try to get an end-to-end test out before we over-optimize it.
Okay.
And actually, I think like Polkadot might also like we also like face the same problem because they already have 1,000, right? So they might have many more, and they'll see the same problem. Yeah, that's my updates on the co-protocol.
Sorry, my connection dropped. Actually, on Polkadot side, they are solving this with the ability to have nominations and then nomination groups, they call them.
Well,
They can like
yes, and
I-
after the election, they still have like 1,000 candidates.
Okay, that's probably a separate discussion. Okay, thanks, Li Cheng. Ivan, I recall you didn't have any updates this time. On my side, the big topic was the version 2 initial consensus. I think we went through it last time. There weren't any big updates since. It just took time for everyone to review, to ask questions, to discuss it. There is still some work in terms of to-dos not implemented and some refactoring to do. There is some code duplication. But generally, it is okay-ish, and we decided to merge it and do improvements later. Some of those improvements were done into additional pull requests. One was on the farmer cleanup. I cannot share the screen with you, but I can send you a link. Here, we basically delete about 7,000 lines of code. Anything related to old commitments and old farming and plotting and even some other supplementary stuff. All that is basically gone. And we just have a new mechanism, which is single file in this particular pull request. And it is much simpler. However, we have lost temporarily benches because they're basically completely different. So there is a bench file still, but it is not used temporarily. And after that, we had another cleanup pull request. I decided to separate them for easier review. This one was on the node and on the consensus side. So basically, we had a lot of these legacy concepts about Eon, about salt, max plot size, and none of those are actually present in the version 2 consensus. So we basically had to delete all of them. And with that, we also deleted the sloth library, which meant we can delete some of the dependencies. So that's why CI was simplified a little bit and some of the minor documentation tweaks. And that again resulted in like over 1,000 lines of code deleted, which is always nice. we still have some work to do, I think, but this should cover the absolute majority of things we need to delete. Something that is left is actually to add new consensus parameters to the runtime related to space L parameter, and I believe there is something else, but those will be added a bit later and separately. This was just a cleanup after pull request. I didn't want that to make that initial pull request very big. Any questions about these two? Okay.
Nazar, when do you think we'll be able to run some of those new benches?
That's what I'm going into next.
Awesome.
So there's this branch. I didn't create a pull request yet because the previous pull requests were just merged, and I need to rebase it on main. Should rebase clearly though. This branch effectively starts at the commit, the last one before October 16th, called move single sector plotting logic into new plot sector function. Basically, this new branch is like a few cycles of first moving logic from that big single disk plot file into a separate module such that we can reuse it. Then it refactors that to have more generic API. And then it is the new bench is created to use that function with generic API. Because in this particular implementation that I built, we were using memory mapped files, which means we have memory slices. But in some cases, we can do something different and we can like tweak things and try things. So those new refactored functions, they actually end up using stdio types, read and write. So we can basically provide the file, we can provide a memory slice, we can provide a vector, we can provide basically anything we want. And that function will just work generically over that. So we have, in the end, several benches. There is one, let me see. On the farmer, we have one for plotting. It doesn't actually write anything to disk. It just does that in memory because writing to disk is mostly a sequential operation. However, I have discovered that it is quite slow. And surprisingly, the slow part is actually iterating over bit offsets. Because we have 20 bits, but we have like megabytes of data. And that's a lot of cycles. And either the library we are using is not super heavily optimized, or we need to do something more custom, more tricky for our particular use case, because it takes about a quarter of a second just to go through that, like plot one single segment, even though there is no like big encoding or anything actually happening there. So in this particular benchmark, there is no cost for the writing to disk. There is no cost for requesting a piece from DSN or Node or whatever. And it's already taken a quarter of a second, which is quite a lot. I actually found some things I can optimize, and I like applied simple optimizations. But I feel like this is something we will need to invest more into if we are going with this approach, or maybe even talking to folks from Supranational, maybe they can do some AVX accelerated stuff or like some kind of other SIMD stuff to make it more efficient. But that's the first thing I would actually focus on in order to understand whether it's feasible. The benchmark not only tells us how much time it takes, it also tells us how many megabytes per second we can achieve. And it was about 10.5 megabytes per second on a single core, and I believe over 100 megabytes or like around 200 megabytes, something like that. For the multi-core, I have 12 cores, 24 threads. And interestingly enough, there was initial implementation that was using parallel iteration over those bit slices. Apparently, cost of parallelizing that is actually heavier than the benefit. So it was doing basically the same stuff for the same time, but it was using 24 threads instead of one. So I just removed all of that, and it was a little bit slower, but it was using one core instead of 24, which makes more sense. We can do different sectors in parallel instead and achieve higher throughput. So that was interesting. Second benchmark added is for auditing. So it is only concerned with trying to find whether there is a solution or like potential candidate solution, whether there is a sector basically that can win. And it has two versions. One is in memory and one is with the file. And you can specify how big plot you want to have, how many sectors you want to have in order to do the audit, and it will audit every single sector. And it is designed in a way that every single sector will basically have a solution, so you can test the time it takes for the whole pipeline. And that was I don't recall numbers, but it was like hundreds of thousands. No, it was about 400 audits per second, I believe. That doesn't seem right. Probably more. But there was another slow path actually in there that we can try to optimize. But it wasn't as bad, in my opinion. And then there was a proving part. No, I believe that was actually 400,000 that I could do per second. And the proving part, a separate benchmark, was also built in two versions. One is in memory and one is in on disk. And that was slower. That assumes that we have audited something and we have a candidate and we need to like build data structure, which is solution, which involves reading slightly different things and also doing some basic cryptography, which is more expensive than just to read from disk. For all of those benchmarks that have on disk implementation, it defaults to some reasonable values. However, it supports and it like uses certain number of sectors and it uses temporary directory for storing data. But it has support for environment variables where you can customize how many sectors you want, and it supports environment variable which allows you to specify a directory. So if you want to specify a particular disk that you want to test against, you can do that, and it will print you number of sectors you can do per second, and it will tell you how much time it takes per iteration. So those are the basic farm-related benchmarks. The other benchmarks we have mentioned before that needs to be done is the time it takes to verify. I didn't write that yet, and it's kind of questionable how useful it is at this point due to upcoming changes, and it is not a hot path for us in any by any stretch of imagination. So that is something that is still left to do. And let me see, what is the other one? There was one more benchmark, I believe, that was left. Time to extract one piece from a sealed sector. That is, by extension, actually tested in one of the benchmarks because we have to like audit a sector, and for that we need to find a particular piece, decode it, and stuff like that. So it's like part of that benchmark. That is slow. But we also discussed with Shamil that there is actually a little bit of a challenge there because previously we had mapping from piece index to where it is, and right now we have like deterministic function. It basically says for this particular inputs, for every offset, this is the pin index. So we need to store like a reversed mapping somewhere to actually be able to quickly find pieces like which sector they belong to in the case we need to use it for DSN. So those two benchmarks, verification and time to extract one piece, are missing. One it will be basically on the node, and the other one will be on the farmer, but we can approximate the extraction time using the benchmark for auditing. I hope it makes sense. There will be a proper pull request probably later today or tomorrow, and we can discuss details in there.
Awesome. Yeah, that makes a lot of sense, Nazar. Go ahead, Shimon.
I'm sorry, Jeremiah. Am I correct that you mentioned a connection between memory mapped files and bit slices, and there is a problem on that? If I'm correct, could you elaborate more on that issue? It seems very strange.
It's not related to bit slices. Basically, what we need to do is we need to take every 20 bits in a sector. For those 20 bits, we need to derive a key, and that which is also 20 bits, and we need to XOR them. So basically, we need to iterate over every 20 bits, and we use a library which basically allows us to call a function chunk this particular piece of memory into this many bits slices, kind of like we do it with bytes, but with bits. And that particular chunking and iteration seems to be quite slow. And we have like a nested one because we have one that iterates over the sector, and then we derive a key, and then for that key we also derive and chunk it into bits, and then we XOR them one over another.
Since it's also seems strange for you, you suspect a library that it's not optimized.
Yes, the library is generic, and if we are focusing on one particular width in terms of bits, there might be some more efficient approach. Just like when we were using sloth for a particular prime, there are some tricks that you can do for that particular prime that wouldn't apply generically. So I feel like there is something there, but just because it's not a multiple of bytes, I don't think there is an efficient instruction in the CPU that can be used right away.
Okay, thank you.
Yeah, and I was trying to compile it not just with release mode, but also with production. So it takes like the whole code base we have and compiles everything into one. So we can do more optimizations, like the compiler can see everything and do its best, but it still wasn't quite working the way I expected. It might also be related to the fact that the parameter space L is actually like a variable, it's not a constant. So the compiler cannot see into the future what that value will be, and it needs to compile a code that will be generic. Maybe we can have like a special case function, and then it might be able to do something more efficient. But I don't know. That's something we need to investigate, I guess.
Probably the issue is that like it tries to hit. I mean, it tries to get the memory, and if it's like crosses the boundaries, it needs to access like to separate like separate words. Yeah, that's the issue.
I don't think that's the problem with retrieval, because that particular test is only. I believe there is a version that works with disk, but there is also a version that works with memory, like directly. And interestingly enough, the file version is actually faster, both for auditing and for proving, which also reads but like a metadata file, not instead of plot file. So it seems like there is something in the kernel that actually helps for some reason. It just caches the whole file if it's small enough, and it is actually faster, but it is still very, very slow. So
yeah, I'll just throw in that I think it's an interesting discussion, but this problem might fall away with the next upgrade to consensus. We might have more byte aligned plotting. So I wouldn't spend too much time over optimizing or trying to resolve this issue right now. But it's great that we identified it very quickly through these benches. That was really the goal here.
Yeah,
so
and we can like pick a different number for space, and we can test how it behaves. Yeah.
One comment on the benches is once you have that PR released, it would be really helpful if you could run those benches and then just copy and paste the output into the chat so everybody can get a chance to see how it's looking.
Yeah, I actually had them. I think I closed the tab already. Let me see. Oh no, I have. So proving takes 2.5 milliseconds, and I can do about 400 proving per second on a single core. So that shouldn't be a big concern. Some of the other benches. No, that's probably somewhere too far. Yeah, I will attach some reference numbers on my machine. Okay. Any other questions about any of this or anything else we need to discuss before we close the recording? All right. Thanks everyone for great work. Thanks everyone on YouTube for watching, and we'll see you next week.